Hello and welcome to this presentation on Kubernetes monitoring and deployment system. I'm Hamad and I'll be going through my final year presentation with on the computing infrastructure major. So first, to understand the project, let us get to know some topics. So what is containerization? So containerization is the process of packaging software and its dependencies into a single unit such that it is isolated and can run anywhere, so it is more portable. So you typically use Docker to containerize. So you write a Docker file and an image is created with the specification on how to run the container, and when you run the container, the image is used inside a container, and you can use one or many containers as per your needs. So what is Kubernetes then? So Kubernetes is a container orchestration system where you can manage thousands of containers with a single command or a single file. So it is much more efficient and is automated. If you were to run 100 containers manually, it would be time consuming and very tedious. Like you would type in docker run, and your application would have to be managed manually. However, with Kubernetes, everything is automated. So a typical example in Kubernetes is this slide. So in Kubernetes cluster, you have a master node or the main control plane, and you have many worker nodes around it. So the control plane will talk to these worker nodes and check on their health and their resource utilization. Based on those parameters, it will assign a container or a pod on those worker nodes. For example, in this slide, this is the Kubernetes control plane on the master node. It is talking to a worker node with Mr. App container running. Currently, the Mr. App container is unwell, so the status is shown to the Kubernetes control plane, and then the deployment controller will close the unhealthy container and replicate the Mr. App container to a healthy one. So this is all automated and specified in the deployment file. And in Kubernetes, you can also create services and create networks such that different containers in different pods can talk to each other. So what are the problem statements? Kubernetes has a steep learning curve. As I explained some topics, there's still a lot to learn, and it is challenging for beginners and even experienced users to efficiently manage and deploy applications. This is because of the vast amount of concepts it covers, and a lot of people are unfamiliar with Kubernetes. So the second problem statement is that there's interaction problems using the command line. CLI interaction can be quite tedious, inconvenient, and error prone. And the third problem is the problem with YAML syntax. So in the YAML syntax, there are white spaces which are significant. Indentation and line breaks are crucial for defining the structure of YAML data. This can be confusing for beginners, and the errors are not clear. So what are the system objectives? The first system objective is to simplify Kubernetes management, improve accessibility, ensure configuration accuracy, and provide real-time monitoring and visualization. So what you do is instead of using the command line or the YAML file, configuration file to interact with the cluster, we will create a user-friendly web-based interface that will abstract the complexity of Kubernetes in a more user-friendly manner. So the proposed solution is to develop a system with a dashboard that allows interaction through point and click interfaces and a GUI. This will also help educate users on terms used in Kubernetes through text and video links and enhance inclusivity and accessibility. So this is the module diagram. As you can see, there are three main modules: the user interface or the front end, the server modules, and the Kubernetes cluster with the Ubuntu server node. So these are all the modules that are visible or to the user. These run at the server, and these are the utility modules. So what are the impact and benefits of this project? So the project successfully explores the feasibility of creating a Kubernetes monitoring and deployment dashboard that simplifies interaction with the Kubernetes cluster without requiring users to work with YAML files or the command line. The benefits of the system are reduced errors, eliminating manual YAML editing, minimizing syntax errors and configuration mistakes, reducing complexity, faster deployment, and easier interaction with the Kubernetes cluster. Uh, I will now show you how YAML editing manually can be error prone. So I have two YAML files here, and the objective or the purpose of these YAML files is to create an Nginx container with three replicas and deploy it. As you can see here, the replicas are three, and it's an Nginx deployment. So what is a deployment? A deployment will target your containers or pods and make sure uh, those number of pods are ready at any given time. So over here, if you see the YAML syntax in the correct deployment file, you can see everything is correct here. However, in the error deployment, there's an indentation error and a typo. So I will try creating both the deployments. As you can see, there's an error parsing the error Nginx deployment. This is because of those indentation and typo errors. However, it is not visible when typing it, and this can be crucial if you are using a mission critical application. And now let me create the correct file, and it is created. So we can see through manual YAML editing, mistakes can occur without us even knowing. So this is also a problem we need to solve. So this project paves the way for wider adoption of Kubernetes and relates to the United Nations SDG 9 of building resilient infrastructure by promoting inclusive and sustainable industrialization and fostering innovation. So let's talk about the entrepreneurship opportunities. So what is the current demand for using Kubernetes in the industry? So OpenAI, has a lot of Kubernetes nodes that it uses to serve its ChatGPT application. So even if you have a company with microservices, you would need to use Kubernetes to manage all of them effectively. So each microservice will be in a container, and they talk to each other. And Kubernetes also allows for load balancing. So when you have a high user load, you can duplicate containers and scale up, and when the load decreases, you can scale down. So the so we know that there's a lot of demand for Kubernetes. So we need to educate users and create awareness of Kubernetes. Entrepreneurship opportunities from this project: we can use this product as a SaaS product with a subscription and tiered pricing, where we can provide different pricing tiers based on features, usage limits, or the number of managed clusters. We can also provide a freemium model and offer a basic version for free with premium features available through a paid subscription. We can use it with custom integration and link it with GitHub. So when code is pushed, the code can be built and deployed in a container with pre-configured parameters, and charge users for using the CI/CD pipeline. We can also make an open source with premium features. So you release a core version of the dashboard, and when this community and adoption is increasing, you release a paid version of the software with advanced features. This is the current Kubernetes node, which is in FIP Lab 1, level 5. So I will demo the system. This is the landing page of the product. The product is called Kube Forms, and it makes Kubernetes interaction simpler. So a dashboard designed to simplify configuration and viewing of resources without the use of command line tools such as kubectl or YAML configuration files. So let's get started. So once we get started, we need to upload a kube config file, And a kubeconfig file is a file that tells the system on how to talk to the Kubernetes cluster or the master node where the control plane resides. So after you upload, it takes you to the deployment page. This shows us the current cluster we are connected to and its IP address, and then you can input your data. So if suppose you want to create a deployment with 3 containers, you put nginx deployment demo default namespace. So a namespace is just to isolate groups of resources within a cluster, and a selector will select the pods so that the deployment targets those pods. Let's call it nginx container and nginx image. So it will go to Docker Hub and pull down the latest nginx image and the default port 80 and protocol TCP. Also, if the user is unaware of Kubernetes concepts, he or she can watch a short video to refresh. So a deployment allows you to update pods that are containers easily, describe a desired state in a deployment, and the deployment controller changes the actual state to the desired state. So you can even visit the official Kubernetes website to learn more. So once you click on create deployment, you see a status code of 201 that is created. And then if you go and view deployments, we can see the current deployment which you made is nginx deployment demo, and once we refresh it, it should be available. And also and to expose our application, we can create a service. So a service is something that allows external users or internal users to connect to the pods. So you create an nginx service in the default namespace, app, select app nginx, and a node port type. Click on add. The target port is 80 and the port is 80, and so you create the service and it is created. Once you go and view the service, you can see there's a service in the default namespace, and now you can click on visit to check. So this is the current running nginx container that is shown. So what this does is it makes it easier for the user to use Kubernetes through input forms and deployments rather than using the command line or manually editing the YAML. You can also view the nodes with the operating system, the number of CPUs and pods, and the pods currently running in the system. You can see all of them are running successfully. Also, you can see the equivalent command line command you will have to use if you wanted to get all this information. This is quite tedious to write as well. That's it for my demo. Thank you.